Hello students, welcome to the video lecture class of production technology. In the previous class already we completed about your arc welding processes and the electrodes what you are using for arc welding process and about their detailed specifications. Today we'll start with another welding process which is named as resistance welding. So first of all, let us discuss about the definition. Actually, resistance welding is a group of welding process where fusion is produced by the heat obtained from resistance of the work to the flow of electric current in a circuit of which the work is a part and by the application of pressure. Here in resistance welding, no filler material is needed. You can see by using this slide, I made you understand. Here it is written that H equal to I square RT. What does it mean? Actually, there are two main factors responsible for resistance welding. Number one, the generation of heat of the place where two pieces are to be joined. Number two, the application of pressure of the place where a weld joint is to be formed. The heat generated in the weld may be expressed by this equation, what H equal to I square RT, where H is the heat, I is the current, R is the resistance of the assembly, and T is the time duration of the current. So here in resistance welding, in the first class already we go through the classification of welding. First of all we are having two types of welding. One is fusion welding in the plastic state and another one is resistance welding. Here we start about the resistance welding. So the resistance welding is it is a fusion welding process. Now it is work like here as per the definition. So here we are having some resistance welding is one of the oldest of the electric welding process in used by different manufacturing industry today. The welding process is made by a combination of heat, pressure and time. Here in the resistance welding process, all these three parameters, heat, pressure and time, all these three parameters is very important to determine the strength of the welding. We can say we can easily join two materials by using resistance welding process. So this number, you can see how much current can flow is determined by a number of factors. That means we are discussing about the current that means the current. So that current can be flow is determined by a number of factors. What are the factors? Which include the material thickness. That means the thickness of the material what we can want to join. Number two, material resistivity. How much resistivity of the material. Then number three, current level. What is the current value. Then last, cross-sectional area of the electrode tips and contact surface. So these are the factors which plays a vital role in the resistance welding process. So some more points in the resistance welding process. Material having higher thermal conductivity is difficult to weld in resistance welding. So the material which generally you learn about the different types of material also, where in material science you go through it. That means in materials, in those material which are having higher thermal conductivity is difficult to weld. Next, so we have to give higher heat concentration on them. For example, you can take some non-ferrous material like aluminium and copper. Next, the strength of the weld is depends on the surface roughness, cleanness of the metal surface. That means you can say the welding surface must be clean before welding. Here in the last point it is clearly mentioned, oil, films, paints, oxide layers should be removed before welding. So before your welding, starting of this welding process, you have to clean all these things. Thereafter you can go through the welding process. So here we come to the different types of welding, resistance welding process. Again, you can see in this slide, you are already having spot welding, seam welding, projection welding, and flash welding. And another one welding is there, that is known as butt welding. That means flash and butt are two different type of welding process. Here in this slide, these are combined. So you can write flash welding and another also butt welding. Now you can see in this figure, you can find where now you see we are having two plates here, and these plates we are applying current onto this. So current is passing from this to this, and here again from anode you can see anode to cathode and cathode to anode. So the heat pressure is how here heat is maximum. So due to that, this area is get fused, and when this area is get fused, we are applying the pressure so that these are sticked with each other, and after allowed to solidify, you can find the weld. So now we start about the first resistance welding process, which is named as spot welding. And for the examination point of view, this spot welding is very much important also. So it is used for joining two or more sheets of metal. That means we will talk about your resistance weld, spot welding process. The sheet to be welded are held overlapping between the two electrodes, one movable and other is fixed. Heavy current is passed through the electrode, and thereafter pressure is applied for the top electrode, may be moving it downward. The fusion of the metal takes place at the spot. The sheet is then moved to have another spot weld at the desired place. The time period of each weld may be 1 to 100th of the second or more. So this is the figure. So first of all, as per your definition is concerned, the spot welding is a resistance welding process in which overlapping sheets, here you can see two overlapping sheets, here is one, another one. Overlapping sheets are joined by local fusion. Here you are applying the pressure, here we are applying the heat also in this here. Fusion at one or more spot by the heat generated due to resistance to flow current through the workpiece held together under force by two electrode. Here you are using two electrode. One is here, another one is here. In spot welding is to be joined overlapping strips. So you are having, as per the equipment is concerned, you are having a transformer. That is here it is written AC type transformer, and that by using this, here we are having two jaw. Here is the fixed jaw, and this one is your movable jaw. So these are the you are having the workpiece which is having lap type joint, when the one is placed, another up top of it. Here you are using two copper electrode in the here and in this position, in this two position. So as per your working, spot welding is to be joined overlapping sheets and plates to be metal of small areas. The pieces assembled in an overlapping manner and placed between two electrodes made by copper and or by copper alloys. Thereafter, a low voltage and high ampere current is passed between them by using these electrodes.